All right. We have distance from a point to a line. If we have any point, and we have a given line, the way that you find the distance from a point to a line is you have to go perpendicular straight to that line. You have to make a segment that is perpendicular to that line. The length of the perpendicular segment, I think this should say from the point to the line. That would be the distance from a point to a line, is you need a perpendicular segment. So when you look at this picture, there's like 3 given segments here, and you have to look at the segments and you have to decide which one of those is going to be the distance from the point to the line. Can somebody name which one is going to be the segment we're finding the distance or the length of? Which segment? I'll give you a hint. Starts with an A. Ends with a C. Right, so we're going to find the distance from A to C. And remember, when you do distance and when we're representing that with letters, we don't put the little line above it. So that means distance. Now, we think back to chapter 1 and we say, how do we find the distance of a segment? Gosh, it would be so easy if there was like a distance formula or something. Wouldn't that be easy? If there was like a formula that gave you the distance. Aaron, what do you think? A distance formula or something? Have you ever heard of the distance formula? Yes or no? No? The answer should be yes. It was in chapter 1. We've done the distance formula in chapter 1. Now, do you remember it? I don't know about that, but we definitely did it. We also did the midpoint at the same time. 1.3, section 1.3. So we're going to refer back to section 1.3. Here's the thing that makes math the greatest subject ever, but it also makes math the one subject that you have to remember everything you've done in the past, because it's going to keep coming back. Section 1.3, we need the distance formula. When you have a right triangle, when you have a diagonal segment on a graph, you can't just measure diagonally. You can measure horizontally and you can measure vertically, but you can't measure diagonally. So what we do with our distance formula is we use the horizontal and we use the vertical to find the diagonal. Did you find it? Jesse, did you find it? Can you tell me the formula, please? I'm going to write it up here, and so is everybody else.
Sure. Well, it's AB, but it equals to the square. You do the
square root.
Yes, square root. You put in parentheses x2 minus x1, end of parentheses, and then you square that. And then you add that with, in parentheses, y2 minus y1, and you also square that as well.
Perfect. And I know I talked about this back when we did this. However, this was a section a lot of you got caught cheating by just writing down my answer key and not doing it yourself. So it's very possible you have no recollection of this because you never actually did it the first time. When I went to college, I had to take an entrance exam. This is going off on a tangent for a moment. you had to take an entrance exam, and they would just give you a test to see how much math you remembered to place you in what math course you should take in college as your first math course. I don't remember much about that entrance exam, but for some reason I remember this question, like, what's the distance between these 2 points, being on there, and I was so proud of myself that I actually remember the formula. Because, you know, you guys are sophomores and learning this formula, and then you're a senior when you take that college entrance exam, so obviously it's pretty important if they think you should know it. So the distance between any 2 points is you're going to find the difference between the x's and square it, find the difference between the y's and square it, add them together, and then square root that answer. What this is the Pythagorean theorem. That says if I go between my x's, which I'm looking at point A and point C, if I subtract my x's, I'm going to have 1 minus negative 3. And what is 1 minus negative 3? 4. So the distance between the x's, or the side of this right triangle, is 4. I feel like I'm having some trouble making this not fuzzy today. Okay. And then we're going to do the distance between the y's. So I'm going to take my second y, subtract my first y. So I have negative 1 minus 3 squared. And what is negative 1 minus 3? David? Negative 4. So from here to here, I'm not going to write negative 4 here, because we're talking about length of a triangle. You can put negative 4. I'm not going to. It's just 4. Because it doesn't matter negative or positive. What happens when I square 4, or if I square negative 4? What happens, John? Sorry, John?
If you square it, it's still going to have to do the same thing twice. So negative 4 times negative 4
It becomes a positive. And if I square 4, that's just a positive. So you get 16 plus 16. So this is like the a squared plus b squared when you do Pythagorean theorem. A squared plus b squared equals c squared, and then to get c you have to square root the answer. So that's what we're doing. We're square rooting it. So we square root 32. Is 32 a perfect square that just square roots right there, just whoop, done? No. So what we're going to do is we're going to simplify it. And we've done this a few times in here and also on your weekly reviews. So if you're still having trouble with this, you need to come see me. You can see me in XH today. We're going to square root by taking out any perfect squares that divide evenly into 32. So what number divides evenly into 32 that I can take the square root of? 16. 16 goes in there how many times? 2 times. So since I can take the square root of 16, I'm going to take the square root of 16. What is the square root of 16? 4. And then the square root of 2 I cannot do anything with. Square root 2. So the distance of AC is 4 square root 2. So the distance from the point to the line is 4 square root 2. Okay? If we wanted that as a decimal, like if we needed to draw a line that was that long, or I don't know, something like that, then you could just type in 4 square root 2, or you can type in square root 32. However you type it in, they should be the exact same answers. Approximately 5.66. But 4 square root 2 is the more accurate answer. This is a rounded answer. So 4 square root 2 is the answer that we would want to have for the most accurate answer. Okay, let's look at example B. I want you to decide which segment you're going to find the length of first. Figure out which segment you're going to find the length of. Jay, which segment do you think we should find the length of? Okay, so I need to pick the segment that's going to start at A, and it's going to go to this line, and then according to our definition up here, it has to be the length of the perpendicular segment. So when you look at all the segments, which one is the perpendicular segment? Starting at A, going to the line of what? One more time, what? D, yes. I'm sorry, I just couldn't hear. D, AD. So we're going to find the length of AD. All right? Now we need to set that up as distance formula. It's just the Pythagorean theorem. So if I were looking to find this length, then I would need the horizontal and the vertical distances. And we get that by subtracting the x's and subtracting the y's. I'm talking because I'm sure you all right now are filling it out. Right? Alexa, can you tell me the two x's I should be subtracting? Okay, so I'll write -4 minus -1 squared plus, Emily, can you tell me the y's that I should be subtracting? Okay, so 2 minus 8 squared. So I'm going to subtract -4 minus -1. Matthew, -4 minus -1, what do I get here? Yeah, -3. How come I hear all these calculators opening? Do we need help with 2 minus 8? It's okay if you do. Austin, what's 2 minus 8? Okay. All right, and then we're going to square those. So when we square -3, that means -3 times -3. Maggie, what do I get? 9. Say that again?
Yeah.
Did you say it can't be negative? Okay. I just couldn't hear what you said. That is correct. That is correct. And then, Denise, what's -6 squared? Yep, 36. Now we're going to add together 9 plus 36. And Raylan, 9 plus 6. Have you guys not noticed I'm deaf? What? 45. Thank you. All right, so we got 45. Now, is that, like, can I just go 5, get one answer? No. So we're going to break it down. And we're going to say, is there a perfect square that does divide out of 45? And Steven's going to help me out. Yeah, Steven. What goes into 45? Times. Okay, are either of those numbers a perfect square? 9 is. So I'm going to write the 9 first. 9 times 5, he said. And I wrote the 9 first because the 9 is the perfect square. This is the one I can simplify. And what is the square root of 9? Anybody? Anybody? 3. And then the square root of 5, we don't know, so I just bring down square root of 5. And we get that our length of AC is 3 square root 5. Now, if we needed to know that approximation, you can just square root 45 on your calculator. It doesn't have to be the simplified version. Or you can do 3 square root 5. Either is going to give you the same answer, which is approximately 6.71. Does that look correct on the graph? Does that look like it's 6.71? Or did I make a mistake? Alex, do you think I made a mistake? Does this look like 6.71? That's right. The scale is going by intervals of 2. So don't just like look at the graph and be like, oh, that doesn't look right because this is like 3 blocks. Because we're counting by 2s. Be careful with things like that. Okay? All right, we've got 4 more things, and you'll add them to your vocab packet when you have time. First of all, perpendicular bisector, which we have already learned the constructions using the compass for perpendicular bisector. So the perpendicular bisector is a line that is perpendicular to a segment at its midpoint. So we've got a line, it doesn't really have to be a line, something that is perpendicular to a segment at its midpoint. So it makes 90 degrees, and then it also cuts the, I'm not on the graph. It makes 90 degrees. It also cuts this segment, I'll just call it segment AB, into 2 equal pieces. 90 degrees and goes to the midpoint. We have the linear pair perpendicular theorem. The linear pair perpendicular theorem. If 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. If we have 2 lines that intersect, and when they intersect, they form a pair of perpendicular angles. Sorry, a pair of congruent angles. I guess I should have drawn this congruent. Congruent. Congruent angles. Then you can assume that these congruent angles are perpendicular, because that's the only way they can be the same with a linear pair. Perpendicular transversal theorem. In a plane, if a transversal is perpendicular to 1 or 2 parallel lines, then is perpendicular to the other line. So if I have a transversal, and it is perpendicular to 1 or 2 parallel lines. Do I have parallel lines yet? Are these parallel lines? Austin, get your head up. Donovan, are these parallel lines? There's no what? I just couldn't understand you, sorry. So now, are they parallel lines?
Yeah.
Yes, okay. So now I have it perpendicular to 1 parallel line. So if it is perpendicular 1 parallel line, it's got to be perpendicular to both parallel lines. In a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. So this one is kind of like what we just did. If we've got 2 lines, and we've got a transversal, and I know that this transversal and these lines are both perpendicular, then that tells me that these that these lines are parallel. So it's just the converse of the previous one. All right, last 2 examples. Oh, yay, more proofs. You don't share the same enthusiasm, I see. Okay. It's all right. Neither do I. It's called acting. Here we go. Use the diagram to prove the perpendicular transversal theorem. Okay, never done this proof before. Who can do first step, first reason? Only one person? I'm scared. You all can do it. Do it. Do it on there. Yes, you and everybody else. Okay, so H is parallel to K, and J is perpendicular to H, given. Show of hands, who got that one right? Yes. Okay. Now we are trying to prove that J is perpendicular to K. We're trying to prove that J is perpendicular to K. In order to prove that, what do I have to show in my diagram? Maggie, what do you think? Okay. I could get to the point where 2 and 6 are congruent to each other, but what do I ultimately have to show at angle 6? That this is a right angle. If I can show this is a right angle, then I can say these are perpendicular. So now you gave me more information than I needed. Can we get to that point where we show these are congruent? Does anybody know what we could use to show that these are congruent? Corresponding angles. Okay, so we're going to go there. The first thing we're going to do, though, is not that. The first thing that we're going to do is we're just going to say that the measure of angle 2 equals 90 degrees. And how do we know that from this diagram? How do we know it? How do we know? Definition of right angles, because well, actually, it's not definition of right angles. What here told me that this definition of perpendicular, yeah. Now, for shorthand, if you don't want to keep writing perpendicular because it's like so long, you can always use this symbol to write perpendicular lines. That's totally fine with me. So now I'm going to say what Maggie and Alex were both saying. Angle 2 is congruent to angle 6. But that's not the only one that's not the only one I could have shown congruent. Let me talk about that in a second. Let's write that down. What's the reason? Not definition. The corresponding angles theorem. Because we know the lines are parallel, so we can say the corresponding angles are congruent. That's the corresponding angles theorem. Now, it did not have to be angle 2 and angle 6. We went with that because that's what Maggie had said. Couldn't I have done like 2 and 7? What would those be? The alternate exterior. So we could have done 2 and 7. So there could have been other ones that we've done. We could have said 2 and 4 and found that angle 4 was right and then did 4 and 6 by supplementary interior, or we could have done 4 and 5. But like there's lots of different ways you could have done this, which is one reason why we don't like proofs, because there's so many different ways and you just never know if you're right. But it's also why I'll give you fill in the blank most of the time. Okay. From here, if I know that these two angles are congruent, I can say that their measurements are equal. Who remembers the reason why their measurements are equal? Angles are congruent. Feel like, who have I not heard from today? It's maybe I've heard. Aaron? Do you know? Definition of congruent what? Yeah. Definition of congruent angles. Go. Okay, so right here, if the measurement of angle 2 equals 90 and the measurement of angle 2 equals measurement of angle 6, what can we conclude about measurement of angle 6? It equals 90. But why? But why? Say it louder. Say it louder. You're right. What? Transitive. Did you hear her or you knew it? It's like we've used that one a lot in here. All right, if the measurement of angle 6 is 90 degrees, now what can I say? Can I go ahead and say they're perpendicular? Yeah, if I know this is 90 degrees, then I know these are perpendicular. Bless you. So J is perpendicular to K. By definition of perpendicular lines. All right, last example. Use a diagram to determine which lines, if any, must be parallel. Explain your reasoning. Do you have any lines in this diagram that must be parallel? Stephen, what do you think? A and B? Why? Because they both have what? Oh, because they're both marked perpendicular. So we have something over here that says if both lines are perpendicular, then the lines have to be parallel. Which one is that? Lines perpendicular to a transversal theorem. Was that you, Rakaya?
Yeah.
Okay. Lines perpendicular to a transversal theorem. And that's it for notes for today. Not too bad? Okay, so I'm going to pass out a worksheet. You'll have a little bit of time to work on that, and then we're going to all put it away and we're going to start a project.